Yeah, Bismillahirrahmanirrahim. We continue for the last week that we miss out the lecture. This one is sequences. Sequences. Basically, for the sequence in mathematics is also called as enumerated sequences. That means that have the uh, sequence from 1 until 10 lah. Okay, and then for the sequence in set. Basically, is a enumerated collection of objects in which repetition are allowed and in order matters. Okay, basically you can jump by the scale of 2 and so on. And then, like you said, it contains members, and then the number of element is called the length of the sequence. Okay, okay, this one is okay, sequence. For example, you have -2, 4, -8, 16, and -32. And then for the set, by default, you should have the bracket. The bracket, and then you have also have the same uh, like set. It contain the member, also called the element or terms. Okay, basically this one for the sequence, you can see this one 1 0 1 0 1 1 0 1 0 and 1. And then for the set, it only contains the elements of 0 and 1. Okay, for the recap, last chapter, if the f is a function from a to b, we can write a implies b lah. And then the assignment of exactly one element of b to each element of a. And then a is the domain of b, uh, a is the domain of f, and b is codomain of image f. This one is a recap. And then we can have also one-to-one function. Okay, it maps the function. And then also we already learned the surjective and bijection. Okay, and then we also learn how to inverse. Inverse from one-to-one function and onto functions. Okay, this one also for the recap. We also look for the composition. We compose the function f and g. Okay, and okay, we also look floor and ceiling. Okay, for today, we take a look of sequences that represent the ordered list of the elements. And then a sequence is defined as a function from a subset n uh, natural numbers to a set of s. And we use the notation an to denote the image of integer n. And then sometimes we call it as a term of sequence. Okay, for example here, we have set 1 and set 2 for the set and natural numbers. And then we can have a sequence. Sequence is a collection of objects which repeat each time. As you can see here, we have set 2, A1, A2, A3, A4, A5, and AN for the terms. And then we have sequences. So we use notation, a bracket AN to describe a sequence. And then most importantly is do not confuse with the bracket used in the set notation. It is convenient to describe sequence with a formula whereby the formula you can define where bracket an where an is equal to 2n because every time it multiply by 2, this one also multiply by 2 and so on until the an until the terms until the limitation. And then we can also define the formula based on the pattern that we can see. Okay, for example, for number one, we can see 1, 3, 5, 7, 9 is an equal to 2n minus 1. Okay, we can have the pattern. Okay, the pattern or sequence. Okay, number two, also same, equal to minus 1 power of n, and so on until an equal to 3n. Okay, this one is if you have the test rule, an is 2n equal to 2n, and then for the n term, we have 1, 2n is equal to 2 multiplied by 1 is equal to 2, and then 2, the term is 5, 2n is 2, multiplied by 2 is 4, 6, and so on. Okay, for the notation, please bear in mind x is the term and n is the term number that you comply to the terms. Okay, for example, you have xn is equal to 2n plus 1 is x 10 is equal to 2n plus 1 is equal, you replace the uh, term number by the terms. 2 multiplied by 10 plus 1 is equal to 21, and so on. Okay, this one is another example. Okay, we have terms and x term number. And then we have string. String also finite sequence also called a string that denoted by a1, a2, a3 until an. And then the length of the string s is the number of terms that is consist of it. And then the empty string contain no terms at all. Okay, because it is empty. And then the length it is 0. Okay, this one is the length for the string. Okay, so far do you have any question? Ada soalan ke? Okay, then we take a look for the summation. Okay, summation. We have. Okay, what does the summation? It represent the sum. Okay, it represent the sum. Okay, and then as you can see, it defined by this symbol. And then n is the upper limit. Uh, and then a is a terms that you can see before this. And then we have j, and then we have a lower limit and upper limit. And then for the summation, you can define like this. And then for the this one is multiplication. Okay, you multiply aj, j is equal to m and am, and then it represents the sum of am plus 1, am plus 2, and so on. And then the variable j is called the index of summation. We index the sum from index 1. Okay, running from its lower limit until to its upper limit n. And we denote this one as index. Okay, for example, if you can see here, we have for sum n, j equal to m, aj. The lower limit we use 2, j2, and upper limit is 6, and then aj lah. And then a2, we start from 2. J is equal to 2 is a lower limit. A3, A4, A5, A6 until A6 for the upper limit. If we put J is equal to 3, it start from A3, A3, A4, A5, A6, and so on until A6. Okay, so far do you have any question? Ada soalan ke? Uh, Okay, this one is another example. If you have the I equal to 1, okay, you start from 1. until 10, the maximum 10. If you have the 100 is until 100. Okay, if you have 50 is pi I 2 multiplied by 2 power of 2. Okay, and then we have I equal to 0. Okay, so we have pi 0 power of 2 plus pi multiplied by 1 power of 2 and so on until pi is 50. Okay. Okay, this one is summation. Summation is you you some summation the output for each character. Okay, of a given collection of string lah. Okay, and then for the formula we have upper limits and we have a lower limit. Lower limit is the terms 2. Uh, okay, and then we have A, formula of the sequence. AI is the formula of sequence. Same goes to here. Okay, 2J is formula of sequence. Okay, for example, if you have 2J, okay, you replace A2, A3, A4, A5, and then A2 is 2, 4 plus 6 plus 8 plus 10 is equal to 28. Okay, how can we express the sum of first thousand term of sequence AN with a formula? Okay, for example, we write for some thousand j equal to 1, j power of 2 lah, and then we list out from 1 power of 2 until 1000 power of 2 lah, and then we sum all of this lah. Okay, and then with this value, you can sum more easily because this one is the upper limit is 6. Okay, for the j, it's not defined. It's not defined. Is power of 1 lah. So this one plus 2 plus 3 plus 4 plus 5 plus 6 power of 1 is equal to 21 lah. Okay, what is the value of summation of 100? J is same lah. Is J is power of 1 lah. Power of 1, 2 power of 1, 3 power of 1 until 100 power of 1, and then you calculate all together lah. Okay, do you have any questions so far? Okay, so we can express the sum of the first thousand term of the sequence AN for the term index. Okay, with AN equal to 2 equal to n power of 2 for whereby the n is 1, 2, 3, and so on. And then the summation here we have 1000 n equal to 1, n power of 2, 1000 summation of 1000 j power of 2 and k power of 2 lah. Okay, and then also it said that Carl Friedrich Gauss come up with the following formula lah. Okay, if you have the upper limit, okay, when you have a formula, the result of summation can be calculated so much easier. For example, if you have 100 here, okay, you have n plus 1 divided by 2, and n equal to 100, and then you can sum up with this formula. Okay, you can find all together is 5050 lah. This one is much more simpler and easier to calculate because if you have the summation of 1000, okay, it is more difficult to calculate. Okay, you can use this formula lah. Okay, upper limit n plus 1 and then minus divide by 2 lah. This one is the formula. Okay, for example, if you have a total of summation of 80, whereby k equal to 1, k is the formula, and then you have to plus 1, plus 2, plus 3. But if you have the formula, you can put n plus 1 divide by 2. N is 80 plus 81 divide by 2. You can have 3240. Okay, same goes to k power of 2 lah. Okay, you list out the uh, k power of 2 n plus 1. Okay, uh, k k power of 2 lah, 2n plus 1, and then you got 50, 51 multiplied by 101 divide by 6, and then you got 42,925. The same goes here, 60, okay, and k power of 3, n plus 1 power of 2, okay, and then 60 power of 2 multiplied by 61 power of 2, and then you got 3,348,900. Okay, the same goes here, j n equal to n plus 1 lah. Okay, you replace the n. Okay, 50, 51, this one 101 and divide by 6 lah. Okay, this one is summation. Summation formula. Use the upper limit. This one upper limit. We put n here. Plus 1 divide by 2 lah. Here also same upper limit. And n plus 1 to n plus 1 lah. Okay, here also same lah. N power of 2. Okay, this one is upper limit an. Okay, for example, this one is another example using table 1. Okay, we have 100 k power of 2 using formula 3. Formula 3, we have is upper limit k equal to 1, k power of 2. Okay, you can see like this. It's minus plus and then 2n plus 1, k power of 2. Okay, here. Okay, and then you got the 297,925 lah. Okay, this one is the formula lah. Okay, k equal to 50, k power 2 minus 49. Okay, okay, this one is just you put the formula, the n. Okay, this one for the infinity. Infinity. Okay, and then we also have the double summation. Double summation. Okay, for the performing the double summation is corresponding to C or Java. There is also double or triple summation. But for the double summation, you do the inner loop first, and then you go for the outer loops. Okay, this one is most importantly, you do the inner loop first, and then you do the upper loop later. Lah. Okay, for here we have the sum j equal to 1 is limit is 2, and then we have sum I equal to 1 and limit is 5 lah. Okay. Okay, and then we do the sum I plus 2i. Okay, this one for the inner loop. Okay, we evaluate the inner loop first, and then we got the sum of 3i, 5i equal to 1 lah. And then we start 3 multiplied by 1, 3 plus 3 multiplied by 2, 3 multiplied by 3 until I is equal to 5 lah. Okay, we do the inner loop first lah. Okay, we do the inner loop first. Uh, Here j, ij, I is the 1 and then plus j equal to 2 lah. This one for the inner first lah. And then that's why we got the I plus 2i, we got 3i, and then we solve the outer loop. Okay, outer loop, and then we got 45. Boleh? Ambil boleh? Kita buat yang kat dalam dulu, baru kita buat yang kat luar lah. Eh? Okay, is another example. Okay, this one for the inner loop we have done, and then we go for the outer loop lah. Okay, I equal to 1. We put the values one by one lah. I 1 multiplied by 1 plus 2 plus 3 plus 4 plus 5 5j I equal to 5 25 and then for this one we got the sum 15 I we replace and then we got 45 okay, this one we solve uh, the outer first and then we go by the inner. Okay, this one exercise of double summation. You can try this one. Okay, first we go by the example. For example, we have outer loop. We have inner loop. Inner loop is j equal to 1. Okay, and for the total we have 3 I plus j lah. And then for the sum 2 we put 2. This one for the outer I plus 1, I plus 2, I plus 3. And then we got for the inner and for the outer. For the outer, this one supposedly 3. This one not 2. Sorry, this one is 3. Okay, and then we have for the outer 3i plus 6. Okay, 3i plus 6, 1 plus 2 plus 3. And then we had got 3 multiplied by 1 plus 6, I equal to 1. Plus 3 multiplied by 2 plus 6 I equal to 2 because this one outer is 2 okay. This one I think is 3 Isn't it? 3 kan? Dia silap tu. Betul kan? 3 kan? 3 kan? Sebab dia punya limit dia 1, 2, 3. Dia bukan 2 3 sebab kita nak we want to solve the inner first Okay, this one is another example. We have sum I equal to 1, j equal to 2, I plus j. And then we solve the inner first. Okay, sum I plus j, I plus 2, I plus 3 because it starts from 2. So j plus 2, j plus 3, j plus 4, j plus 4 and 4. This one is not I, is j. Then you got this one. Got you got j plus 2, 3, 5, 9. Okay, j plus 9 then you replace the here sum I equal to 1. Okay, I plus 9, I plus 9. Okay, 10 I plus 9 plus I okay, plus 10. Which one Ini. This one j I plus j is equal to j plus 2 I plus j. Okay, sorry, this one I plus 2 lah. Correct. We plus the j first lah. Okay. I plus 2, I plus 3, I plus 4 lah because j start from 2 lah. And then we got I plus 2, 4, 9 I plus 9. Okay, then for the outer loop kita dapat berapa Kita dapat we got I plus 2 plus 3 plus 4 we got 15. And then we got 2 plus 2 we got 2 plus 3 2 plus 4. Then 3 plus 2 3 plus 3 and 3 plus 4 we got 45 Okay. Okay, this example you upload to Padlet lah. Okay. Okay, another example wait I think we rest a little bit and then we continue after this Boleh kita rehat sekejap.